Hello, everyone. Welcome to today's community call. We have a few speakers for you today. Going to show off some of our latest demos. And then we will also be at KubeCon next week. So we have Love actually already on the EU side, and some of our speakers are from Europe today too. So we'll be heading there very soon. If this is your very first community call, let's go through some logistics real quick, and then we'll get started with the fun stuff. So we love to have questions come in as you see the demos, and we love to get all of your comments as well. So feel free to chat in the YouTube chat and put your questions, comments. We're watching it throughout the whole show, so we'll make sure to address them as they come in. And then also we're watching the the Discord general channel as well. So if you're in the Discord, feel free to add your questions there, and we'll make sure to address them during the call too. While we're getting started, if you want to put in the chat where you're watching from, it's always really fun to see everyone from around the world checking in. So
Mark Hosnell said hello.
No. I don't know what that one was. Anyways, but now I guess my computer is telling me where everyone's saying hello from. But also, this is a good reminder that if you aren't already in Discord, it is a great place to be, not only to chat with everyone during these calls, but also just as you're getting started on your Dagger journey. Everyone in this call, and actually, all of our commanders, all of our team is in Discord. So we're happy to help you if you have any questions on not only these demos, but anything you're working on with Dagger as well. And if you see these demos and you say, hey, I have a really cool one too, and I'm not quite done yet, but I'd love to show it off, just ping me. We're always happy to show not only complete demos, but also works in progress. So just ping me on Discord. I'm happy to get you on the agenda. So let's see who we have here with us today. Okay, so we have a few people. Diego and Mateo, do you guys want to introduce yourselves?
Sure. So, I don't know, Mateo, want to go first?
Sure, yeah. Well, thanks for having me. Well, I work at CERN, so European Center for Nuclear Research, and actually work on a European project together with Diego. It's called Inner Twin. So the goal is to support digital twin applications in science, which are strongly relying on artificial intelligence. I'm also part of CERN Open Lab, which is basically a collaboration between CERN IT. I mean, a framework to establish collaborations between CERN IT and industry. So I'm really happy to be here today. Yeah, this is Diego.
Awesome, thanks for being here. And where are you calling in from today?
Well, pretty close to Geneva, Switzerland.
Nice, awesome. And we'll see you at KubeCon next week too, right?
Yeah. Looking forward.
Awesome. And Diego?
Yeah, so I'm a technologist at INFM, and I'm working, that is the National Institute for Nuclear Physics in Italy. And I'm also working in InterTwin, where we develop this cool stuff that Matteo just said, and I'm one of the maintainers of the solution proposed there. And I'm a Dagger commander too, so
yes, we love. Yes. Yeah, a lot of you have probably seen Diego's demos from the past year. It's been awesome to have you as a Dagger commander. And then Lev, we have you calling in from not your usual spot.
Yeah. Hey, everybody. You can hear me, right?
Yep.
Perfect. Thanks. I mean, I'm normally in the Bay Area, but this week and next week I'll be in Europe, and today I'm calling in from Hamburg, Germany. So I'm a solutions engineer at Dagger. I work with our community and our users and our customers to help them explore, adopt, and get the most out of Dagger.
Awesome. And then Jeremy is on vacation this week, so I have Kyle as co-host today. And all of you probably know Kyle. If you're at any part of your Dagger journey, you probably know him from all of the YouTube, amazing YouTube tutorials that we have. But Kyle, do you want to give people a little bit of background on what you've done in the past?
Yeah, definitely. Yeah. So I'm Kyle. I'm on the ecosystem team here, and your co-host today. And I'll try and bring some of Jeremy's energy to the stream. And yeah, let's have a good time.
Awesome. And if you see, there's a lot of awesome tutorials that Kyle and Jason, Vikram, everyone from the ecosystem team has been trying to build with these agents. So if any of you are seeing those YouTube videos that they're building, we're also always open to feedback. So please let us know as you're seeing those come out. If we can change anything or improve anything, we want to know so we can make them as best as possible. Okay, so let's get started. Diego, do you want to? Which screen should I share? Yours or?
So I go first.
Okay, awesome, perfect. Let me add it to the stage. And it says remove other media. Oh, there we go. There we go. Okay.
All right. So yeah, this is just really quick. All the institute that we mentioned before. I leave you the link just for more curious of you, and you can find all the information that you need if you're interested to know more about these activities. And just let me introduce the concept of digital twins, because I think it's important also for all the things that we are going to look at next, because they are pretty much a peculiar system. I like a lot the definition that you see here, so that are the digital representation of the real world system. And this means that, for instance, no, not this one. I want to say that, yeah, I have a wildfire and I want to project into the digital world what can happen if a wildfire spreads somewhere. I need a digital twin of the reality to simulate that. Same for the flood impact modeling. And in science, in particle physics, for instance, we also have this need. And it's related to understand how our detector works. So this gigantic camera that are recording everything that happens at microscopic scale, yeah, they are complicated, time-consuming, and energy-consuming to simulate it, to understand. Maybe machine can do better and describe our detector with less effort. I say maybe because it's an open field. And same for different kind of activity where you are very sensitive to noise, and you want to simulate the effect of noise on your pictures or on your measurements. So yeah, a lot of heterogeneity already in the use cases that shares a common set of needs. And this common set of needs drive the development of intertwin project. And yeah, an engine that we can share with all the previous use cases, and where we can build one layer over the other with a transparent ecosystem, with a transparent interface. So you can use it for different things, as we saw before. But the most important challenges that we want to tackle today, that drove us to use Dagger for many things, is, okay, we have several frameworks that should be able to use a common platform that can distribute the application for the digital twins. We want to offload the heavy task to a number of remote sites, because heavy payloads should go to supercomputers, for instance. And then we want to maintain kind of an interoperability between all these frameworks. And this is granted for us just using cloud interfaces. And we will see that is not that simple. Okay, intertwin, you have all the details in the link, so I do not spend more time on this. It's an effort of different communities, that both from the providers perspective, cloud providers, supercomputers, quantum systems, all this kind of stuff, and also community, so who actually builds digital twins.
That's awesome.
Yeah, cool, right?
Yeah, it's amazing. Just the amount of things that are included in that, and you're going to be talking. Both of you have a talk at KubeCon about that project, right?
Yes, awesome. We are going to have a similar discussion at KubeCon. There are some extras, of course. I don't want to spoil too much, but it's along this line. So yeah, the project and how we manage this heterogeneity.
Great.
On Friday.
That's awesome. Very cool.
All right, so the challenges, just to recap, we have several distributed heterogeneous resources provider, HPCs, HTCs, so batch system mainly, and cloud. And we want to access them through a common interface. First problem then is how we can access them. And then where Daggers come in is maintain a software that works in a consistent way on all these platforms, on all these backends is a challenge, and a challenge that we want to take, especially for checking that our images are behaving the same on all our providers. And we ended up already to have a zoology of this image. Some needs a particular format like Obtainer or Enroute from NVIDIA, but also you have environments where you need to load extra libraries to make things work, and so on and so forth. So these kind of challenges are particularly hard to solve in a non-Dagger way, let's say. And on the other side, rightfully, users usually don't care how you do that. They just want to run their things and that work out of the box. On the other hand, the good thing is users also starting, or in science, since a while, converging toward a common set of tools that are cloud native, if you want to name it in that way, for machine learning and data science. So this gives us some knobs to turn. We can play around a situation like that, okay? So everything is converging toward Kubernetes. We can take this and have a plan at least. And the plan is a solution that we are developing in Intertwin that just joined the CNCF sandbox that is called Interlink. So you can imagine like a generic, a universal adapter for Kubernetes to delegate it to offload your container to a remote site. So you have your Kubernetes cluster, you launch a pod, and the containers will run somewhere else in a batch system, in a supercomputer. I'll go fast on this because it's one of the modules that we are going to use, but it's not the central part of the presentation. So now we have this powerful tool that solves the problem number one of the presentation. We have a Kubernetes interface where we have no CRDs. Everything is transparent. We can just attach a Kubernetes cluster to any remote resources that we can reach. So we define a pod with some configuration, and this will land on one of the supercomputers that is part of the collaboration. It will do the train of some model and will respond with a result in some kind of archive. In this case, is MLflow system. Good. The introduction is finished. We have this kind of tool to be used, and the software that runs on these platforms, on Kubernetes with several frameworks, has to be compatible with all our backends. And yeah, a lot of power, we have a lot of responsibility too. So we need to guarantee our users that everything works just as fine. And so we need reproducible results and a way to orchestrate different workflows for different backends, if you wish. We could do, and we did try to use with the usual CI system, but I think we can conclude that we couldn't do without either being heavily locked in by the internals of the CI system that we used, or in any case, we could not avoid to have a copy-paste nightmare somewhere where you end up with some solution that works, but it's different to maintain if they change something in the way you build your images, for instance. So we needed a starship, spaceship for our interspace, if you wish, and the solution that we are presenting today is based on Dagger, of course. I think I don't need to introduce all the feature that Dagger provides out of the box, but just to refresh, what we were looking for is especially something where we can program our pipeline in a declarative way. where we can manage all the things in the most CI agnostic way possible. And then there are some bonuses that we are glad to have that are caching artifacts. If we need to rebuild new images in different formats, it's good to have. And also the observability to understand what happens. Of course, the LLM, the new cool tool in town, is pretty interesting, and we are looking for that. It will not be presented here, but maybe you will hear from us after the KubeCon.
Maybe Kyle could give a quick intro into the LLM feature in case there's people who have joined who haven't tried it out yet.
Yeah, I mean, if it's not part of this demo, I could show, or maybe Lev's gonna show it too.
For anyone who hasn't tried out yet, we did. If people are watching and you're just starting to get to know what Dagger is, we have a Containerize Your Agent channel. So if you have any questions on that, either during these demos or afterwards, that's a great place to go because we can help you out with the use cases like Diego was mentioning.
Yeah.
So, are Kyle going to show something or?
Oh no, keep going for it. Sorry.
Yeah, go ahead.
I just want to mention for
okay.
people watching who don't know about it.
Okay, so so definitely it seems like we have our reusable workflows. Then for reference, I leave some details, but Matteo will go through more thoroughly. Okay, so we are at the point where we have our pipelines that, by the way, the other very cool things that we have right now is that we can test the very same machinery just from our laptop and not waiting for the pipeline to run or to waste any kind of resources. So yes, you have your pipelines, an engine that can translate from one scenario to another, pretty cool. And you can already imagine how useful it can be, but Matteo will show you in practice. We have beneficial observability, so we can see even when we try things in local, we can test and we see how it's going and what's happening inside the pipeline. Having this insight is very cool. I will skip this. There is a lot of material. I thought to leave some material too. So we are planning to understand how we can use this to fix basically my typos and when happens and when avoid wasting resources before submitting some task. I leave the link. If you pass me any other material, I can add it to the slide later. So, all right. The core of the presentation is that we managed to make these two universes, the Dagger verse, if you wish, and the interspace to talk to each other. And this provides us with some cool features. So we can now execute Kubernetes cluster or Kubernetes workflows on our supercomputers just from inside a sandbox that is provided by Dagger. What does it mean is we're going to see a pipeline that Bootstrap and ephemeral Kubernetes equipped with interlink that is going to talk to a supercomputer, a Euro HPC supercomputer in Vega. So for time reason, we are not going to wait and to see everything, but Matteo will show the detail of the implementation. And we can reuse at this point the very same modules for different backends, just changing the last mile of the implementation. That is really the killing features for us at the moment. Of course, if you can get on board with LLM, we are also very, very happy. So yeah, I just shut up now. I leave the floor to Matteo and enjoy.
Right.
No pressure, Matteo.
Yeah, it sounds like
Yeah,
Dagger
yeah.
can do everything.
Absolutely.
So I'm excited to see this.
Yeah. So,
And Matteo, while he's getting his screen up, Diego, while he's getting his screen up, do you want to share the link for the CNCF project that you're mentioning in the chat? And that way people can check it out while demoing.
Yeah, sure.
Let me add to stage. Let me remove this and add Matteo's screen. Perfect. There we go.
Okay.
I think it's just loading. Okay, you're good.
So let me know when I should start.
You're all set.
Okay, great. So thanks Diego for the intro, and now let's see more details what we're actually using Interlink and Dagger in this case for. So as I said, Diego and I both work together in this project, but in different parts of it. And what I'm actually working on is developing this library, which is called i2AI, which provides it basically works as a toolkit to help scientists scaling the AI workflows to cloud and specific and more importantly to HPC. Providing features such as distributed machine learning, hyperparameter optimization, supporting frameworks for machine learning logs, so to store and track machine learning logs and models such as MLflow, and connecting, of course, to all the libraries to connect the infrastructure, so to the lower level, and providing also some interface, which could be a CLI or a Jupyter interface. So when I talk about distributed machine learning, I mean running the training of your model, exploiting as much as possible the resources that you can find on HPC. And this can be done using a strategy which is purely data parallel. So distributing, replicating your model on multiple GPUs and have them, let's say, work on different partitions of your dataset, or having a hybrid strategy in which you have both data parallelism but also model parallelism, which is pretty popular nowadays when a model cannot fit in a single GPU, so like very large models. And to do this, we base, let's say, our software on top of popular backends that we call backends, such as PyTorch, Horvath, DeepSpeed, and Ray. Another feature, another key feature is distributed hyperparameter optimization. So in a similar way, we want to exploit HPC resources to run in parallel multiple trainings using different hyperparameters. So starting from a tuning configuration, our trainer will be able to launch, exploiting different multiple nodes. It will be able to launch, different trials and track them over time, stop them, and use using RayTune as a backend. Let's see some examples of scientific digital twins that use this toolkit. So here I'm showing only two examples because I have not much time, but we have a use case from the environmental sciences in which they're developing an AI-based hydrological model to forecast the effect of climate change in terms of drought. And the other, on the right, you can see a use case from physics in which we are helping them to train AI-based methods to denoise the signals from the Virgo, captured from the Virgo interferometer to detect gravitational waves. So here you have an example of some, let's say, preliminary results in terms of scalability. So one of the main goals for us is to study the scalability of these models on HPC and to compare how these different frameworks or backends like Torch, Horvath, and DeepSpeed compare for each different model. So we can study the speed up and also the energy consumption, so the energy benchmarking. But as I was saying, we're also interested in optimizing these models in terms of scientific, I'll say, metrics. In terms of, so in order to produce more and more precise digital twins. And so here we have an example of hyperparameter optimization. And with, let's say, the integration in i2AI, which is based on RayTune, we were able to improve by almost 75% the validation loss compared to the, let's say, initial guess of the hyperparameter. So this is all to say that we are really interested in developing a toolkit which is able to distribute the workload on HPC resources and like on multiple nodes and multiple GPUs, reducing the overhead for scientists. So the engineer overhead. Okay. So, but how do we ensure that our software is always consistent? This is the main problem. So as I was saying, what we're developing is an abstraction layer. So the input on the left, you can see we have some sort of scaling configs and tuning configs. So these are provided by the scientists. And then there is our trainer, so the actual abstraction layer, which is based on popular backends for distributed machine learning, such as PyTorch, DeepSpeed, Horvath, and Ray, which will actually talk directly with HPC resources. Okay. So for us, it's very important then to ensure that this yellow box is always consistent and we're not introducing bugs or inefficiencies. So first thing, of course, I mean, it's normal. We run some tests, and some of the tests are easy to be run because are kind of simple tests. So for instance, we have an abstraction for loggers. This can be run on your laptop. Same for utility functions and some other tests. That's totally fine. So these tests can run anywhere. But there are some other tests that cannot be run on your laptop, but they intrinsically need to be run on HPC. An example could be verifying that the distributed strategies are assigning the correct ranks to each worker. So here in this picture, we can see how each worker, each process, which is assigned to a specific GPU, is receiving different ranks. And these ranks are needed by the workers to know each other and to share information, to share gradients in terms of in the context of distributed machine learning. So first thing we need to make sure that the code is actually distributed in the right way. Another set of tests that we run is to make sure that the collective operations are actually working. And when we perform a gather operation, the result of the gather is actually the concatenation, if you want, of some variables on all the workers. And similarly for the gather or other collective operations. Other tests that we are interested in running on HPC are, for instance, verifying that the checkpoints generated during training are correctly stored and reloaded, and also we perform, let's say, integration tests in terms of concerning training and tuning. So we run end-to-end training and end-to-end training under tuning. So we have a tuner, and each trial can itself be distributed. So we have two layers of distribution. And all of these, I mean, it's pretty obvious that cannot be tested on your laptop, because if you're lucky, you only have one GPU, right? So we need HPC resources to run these tests and to ensure that the software that we are developing is always consistent and we're not introducing bugs, so that the scientists can actually rely on it for their scientific workflows. So
yeah, Matteo, just
yes.
a comment on this. So I think what is also very interesting is that since all these resources on supercomputers are kind of have a cost, of course, you don't want to waste with trivial typos or any kind of problem that you have. So one possibility that we have and we might explore is to have a sandbox environment that also simulate how the supercomputer works. So having all the tools there with similar libraries, so we have kind of a dry run before submitting. And this, of course, can fit into a module. It's not there, but it's one of the possibilities that we keep open for the future. And yeah.
Yeah, I mean, indeed, if you have the resources or if you're able to simulate them, yeah, of course. So
yeah, no,
yeah.
you don't have to simulate everything, but at least to be sure that they start, and then you have no trivial issue before submitting the real one.
Yeah, indeed, yeah. So just if you're curious to know how we run the tests, because usually you run PyTest. I mean, the simple tests are run using PyTest, and you just launch PyTest straight into the terminal, right? But in this case, we actually need to add an additional step before. So first, we have a distributed ML launcher, it's called, which will spawn processes on each node, and a number of processes, for instance, equal to the number of GPUs, so that each process is assigned to a specific GPU. and then each process will actually run PyTest. So launch the tests. And that, but each test before actually running, I mean, since it's meant to run in a distributed, how to say, in a sort of like distributed environment, so it needs to communicate with the other processes. First thing, it will set up the collective communication. It will connect to the collective communication backend, which is actually being the interface to the HPC resources. So this is pretty much the high level picture of what's really happening under the hood. So let's try to wrap up and put all together, everything together. So how do we actually do all of this in practice on HPC? So currently we have our code and CI workflows hosted on GitHub, but how do we connect GitHub to HPC, or in other words, how do we integrate HPC resources into GitHub? Well, first problem is, as Diego was saying before, if we rely on GitHub workflow and GitHub Action and GitHub workflows, it becomes kind of complicated for us to replicate the workflow locally or on any other kind of resource. So Dagger is providing this functionality to abstract out from where you're actually running. And second, very important feature is that it allows to deploy services, which are very important because we will see later why. But deploying services into the pipeline, it's a key enabler of our results. So how do we do this? We have a Dagger pipeline which is running on GitHub, and which is deploying an interlink service. I mean, it's deploying a K3S service, on top of which an interlink virtual kubelet is deployed. The containers are built into the GitHub, the Dagger pipeline, which is running into the GitHub action space. And then at some point, when some of the tests are passing, then the container will be pushed to some Docker registry. And then interlink will make sure that the container is actually pulled on HPC, converted, and the tests are actually part of the tests are actually being executed on HPC. So the tests that need to run on HPC will run on HPC. And once the tests are passing or failing, when tests are passing, the pipeline will continue, and we will so to see in more.
Sorry again. Just to stress one thing, that the other feature that is pretty cool is that to integrate K3S, in this case, you had to do nothing at all, right? So you had to import the module that already exists. You look at in the Daggerverse and you import that, and that piece of the puzzle is already there for you. Same kind of with interlink. We are we are going to maintain a module for the interlink installation. So if you wish, the core part comes for free just with the modularity of Dagger, and then everything else is kind of a plugin into that. So this structure is pretty flexible and just what we needed, basically.
Yeah. Let's say, I mean, it was not everything for free, but yeah, luckily now things are good.
Of course.
No, but yeah, I mean, also, but yeah, indeed. The nice thing of the modularity is, indeed, for instance, K3S was indeed something that I just reused as it was. So yeah. So let's look at the pipeline. So what's really happening? So first we build the container. We test it on GitHub. The container is then converted to a Singularity file. It's after the conversion is completed, we deploy an interlink service on top of K3S. We launch the tests on HPC using the Singularity file. So the Singularity, the Docker file, which was converted to a Singularity file. And after that, if the tests are passing, both the Docker container, so both the Docker image actually, and the Singularity image will be pushed to two different registries, just because, I mean, you cannot push Singularity images to GitHub Containers registry or to Docker Hub, but that's fine. So, in this way, we can actually distribute the containers with our community and the use cases can also build on these containers. So we have an A2AI Dagger module as well. I put the link below here. And actually, this A2AI Dagger module contains 3 types. So the A2AI type, which takes care of basically the A2AI container lifecycle, the interlink type, which basically is based on K3s. So basically, what Diego was saying before is using K3s under the hood, and then is deploying interlink, starting the server, the service, and so on and so forth. And then we have the third type, which is Singularity, which actually allows to convert a Docker container inside Dagger to a Singularity file, and also push into the publish and so on and so forth. Yeah. Okay.
Yeah.
Forgot to say this.
I don't know. What do you think, Miranda? If we have time, maybe Matteo can go through these modules live.
I think, yeah, I think let's check out like one of those modules. But I think, yeah, this is amazing. I'm honestly just been absorbing how cool it is that like you can build one of these modules, and just continuously reuse, and not only for your use case, but like you've now contributed this type of stuff to the rest of the community too. It's amazing. So build it once, use it for multiple things is always nice. But yeah, Matteo, do you maybe want to go through like one portion of the demos? That'd be awesome.
Yeah, indeed. Yeah. I mean, I was pretty much done anyways. So yeah, let's go there. So yeah, I mean,
we see your slides. I'm not sure if you want to show VS Code.
Oh, okay. That's interesting.
Or
So
we see
you still
no, we see your whole screen now. So you just probably, I don't know if you want to pull down the slides.
Okay. I actually did that. So okay, maybe I can try to reshare. That's a bit weird, to be honest.
No problem. No,
That's really cool stuff so far. I mean, just like blown away with some applications.
Yeah, just looking at all of that is amazing.
So when you make first contact with aliens, make sure to tell them how cool Dagger is.
Will do.
Thank you.
He's like, we already did, Kyle. So
yeah, exactly.
Tell you.
We can't tell.
I'm just this is amazing. It's also just so cool to see how many tools are in the ecosystem, and at the end of the day we still have all the same problems, right? You still need to be able to test, you need reproducibility, all these things that like a lot of people get confused on Dagger and they're like, okay, what does it do specifically? And then these type of use cases are perfect, that like it can really do many things because it gives you the ability to just get that feature set for whatever use case you have. Like look how amazing and complex this one is. So it's very cool to see. Sorry, you want to go for the demo?
Yeah, you mind zooming in just a little bit?
Yeah, sure.
Thanks.
I have a large screen here, so okay.
Yeah, maybe exactly.
Good,
we can start from where you instantiate K3s and then interlink just to give an idea.
Sure. Yeah, exactly. So I have everything here prepared in my cheat sheet. Otherwise I always forget. Yeah. So what's happening now it will take a minute, so let's just have a look at it. So what I'm doing, I'm actually calling the interlink function. So if I go A2AI is my main module, right? So if I go into interlink here, we will see that actually it returns the interlink type, which I have here. So let's just have a look. So I mean, what's really interesting here is just the values, pretty much. So the values to set up interlink. So it's a secret. It's in this case I passed it as a file. So as you can see here, so I'm passing the values to start up interlink. And what this values file contains is, I mean, Diego can give definitely more details than me, but it contains very much the authentication tokens that my local interlink deployment needs to know to connect to the interlink sidecar running on the HPC. So this is a as a very important step, because in here I have basically my credentials, let's put it this way, to connect to the HPC or to the, let's say, to the interlink server living on the HPC. And then so now let's have a look at the interlink. So what's going on in here? Let's maybe move it to the left so I can show you. To show you, yeah. Then we have interlink cluster. So this is basically just a service. It's returning a service, and what this service is actually doing. So we actually have a K3S service which has some name. Yeah, and that's pretty much it. So we start the service, and then inside the service, we actually deploy interlink. So that's how we deploy interlink on top of the K3S. So as you can see in here, we are setting the values. So that file containing all the credentials that I need to connect and to authenticate to the remote HPC, it's there. Yeah, and then that's pretty much it. So we do Helm install, and we have an interlink. We sleep a bit, and that's it. So now below here we can see that the interlink service is up. So yeah, I mean I can probably just have a look.
At this stage you have a Kubernetes cluster running and a node that is not a physical node, but it is the one that will submit jobs to the cluster. So a virtual node.
Let's see if it was.
See if you have also the client. Yeah, cool. Okay.
I think so. Yes. Okay. So yeah, of course. Yeah, I need to tell him where to connect. Of course. No, yeah. Interlink. Yeah. I need to tell him. Yeah, it was here actually. Why did I copy the first time? Yeah. So yes, I also have a client. So again, this is something everyone could use, even without having to know anything about it in AI. So you just yeah, what's happening here is that I'm passing the service endpoint to these Dagger functions. So yeah, and basically I'm just calling the the client is just container and opening a terminal. So if I get the pods, here we have the pod. So that's the interlink virtual kubelet.
And Vega is the name of the supercomputer. It's a Slovenian supercomputer in Europe.
Wow.
And it's also ready. So
that's
so yeah.
Wow.
That's why it was sleeping before.
Okay.
Wow. That's awesome. And for people watching, like, yeah, sorry, I don't have many words. It's so cool to see this type of stuff. And so it's for people watching, we're watching also the first time this demo. So we're also absorbing how cool it is.
Maybe if you want to see something more, I have this, but this is kind of quick. So when I was developing this, I always want to make sure that my deployment was actually working. So I created this function, which I just called test of loading, which is running some dummy tests. So one will be a successful pod. The other is a pod which is expected to fail, actually. And the third one, I don't remember. The last one is expected to time out. So I just want to make sure that, how to say, my local interlink deployment is actually able to to behave as it should. So let's just get out of the K3S. So okay.
While you're doing that, question came in. Is this this is entirely local, right? So not talking to external compute.
No. I mean, this is on a VM, but it's considered as it was on my laptop. It's
the only thing that goes remote is now when we submit a pod that is targeting the virtual node, the Vega node that you see there, then it's connecting, it's sending a request to an endpoint in the supercomputer.
And that's through Interlink, right?
Sorry?
That's through the the Interlink project. Yeah.
Yeah.
Awesome.
Let's see. Let me show you the pod. Okay.
the second one. Yeah.
Yeah. So now I'm opening the client again, so I can show you that there is a pod, which is actually running in the K3s, and this pod has been assigned to the virtual kubelet, to the interlink virtual kubelet. So,
That's great. And another question coming in is, what's the local resource consumption like? Would it need a beefy machine?
I mean, to be honest, to run Dagger, maybe a little bit of storage because of the cache, but no, apart from that, no, not much.
No, just to give you an idea, when we do some preliminary scale test of all this stuff, it's kind of supporting order of 1,000 pods running in a matter of 4 CPUs, 4 gigs machine. Nothing special. It's all virtual. I think even the normal kubelet will have extra operation to do with respect the virtual one. So it's even lighter than a normal kubelet. And yeah.
So in this case, I see that the pod keeps being in pending state, but that's because today the queue on Vega is pretty full.
Yeah, that's the nice thing of the demo.
Yeah.
Because we're demoing, that's why. No, but this is really cool. Thank you so much for showing this. And I'm really excited to see even more of this at KubeCon. If anyone watching is going to be at KubeCon, you know, I know Diego, I'm sure we'll meet up at the booth and, you know, hang out for a bit too. And so, you know, and go to their talk. This is another shameless plug for their KubeCon talk where they'll show off more of this stuff too. Yeah, this is very, very cool.
Yeah, awesome. Yeah, thanks for sharing this.
Yeah, thank you so much. And I added one of the modules you're talking about, but I know you mentioned a few, so I'm not sure if you want to link to a few more. But let me pull up Lev's slides too, because he also is building an agent as well. And want to show that off too. So what are we talking to aliens in yours, Lev?
We might. I don't have any slides. I don't have any slides at all. So also, by the way, I can only see. I'm still seeing the other screen on YouTube.
I can see your VS Code and your Ghosty.
Oh, okay, cool, fantastic. I'm looking at YouTube on my phone just to make sure, and I see the Dagger logo. But maybe there's a delay. Oh, there's a delay, right?
Yeah, a little delay. Yeah.
Yeah.
All right.
In case we need to bleep out or anything.
Yeah. Okay, cool. So here we are. Thank you, everybody. Thanks for that great demo. It was awesome to see. So what I'm going to show today is a little agent that I've been working on. So last week we had a little hackathon at Solomon's house. A couple of folks from our community showed up and worked on some agents using some experimental Dagger technologies. And I was able to get one to work specifically with the goal of doing some like QA on my own modules. So I published you know a handful of modules in the Daggerverse that do different things. Like if I just search for myself, you'll see there's a bunch of modules. One of them that's useful is Docusaurus. So if you're running Docusaurus docs and you want to like create a sample of that for yourself for testing or previews, it's a really great module. But there's a bunch of others, and like I've been working on these for over a year. Some of them are like very up to date, some of them are not. So I was thinking of using some of these cool new technologies to help me just like be a better maintainer of my own modules. So I started working on this agent, and it's a very simple thing. So I have like the common pattern right now is an agent has like it's a Dagger module that takes some instructions, and then it's a different Dagger module that provides like an environment for the agent to do its work. So I'll just walk through and show a quick overview of what that looks like here, where like this is my workspace or environment where basically I'm creating a container with Alpine in it and also running Dagger nested. So this is like using Dagger and Dagger to test Dagger modules. And this is actually a common question we see in our Discord. People are always asking how to test out a Dagger module. And like this is the secret incantation using this experimental privilege nesting flag in your with exec will allow you to actually pass along your kind of container resources onto Dagger so it can continue to launch containers. Anyways, this is a very simple module. It basically can do 4 things. It can read files, write files, You can install Dagger modules, and it can build Dagger modules to extract their functions. Oh, sorry, one more thing. It can get the version of the Dagger engine that's available to it. So using this like workspace that the agent is able to operate in, I then have a separate module that basically tells it to do QA. And do QA is a Dagger function like any other that accepts an optional module as a string, and it'll grab that workspace and it'll execute a prompt. And the prompt is pretty long. We don't have to read the whole thing, but it's essentially saying you're a great QA engineer, do some QA in the modules that you're provided, and then give me a report back with some suggestions on how I can improve my module, and give me that file. So let's just see this in action. Going back over to Ghosty here, I'm inside of the Dagger module that contains both the environment and the agent module itself. And I have this function called doQA, and I'm able to pass it a specific flag, right? So here I'm passing this Docusaurus module as an argument. And then once it's done, it's going to return a container basically. So I'm going to grab this QA folder and export it back to myself, to my laptop, so we can look at it. So this starts to do stuff, and you can see that the prompt was executed. You can see, and we can actually follow along in Dagger Cloud as well. So here, you see the prompt that I was given. You'll notice how that template was kind of processed. So it injected the module I passed into the prompt, and it kind of gave it these instructions, and the agent starts to work. So you can see it's grabbing its workspace, it's getting the version number because it's going to need that later when it writes its report, and now it's it's installing my module. It's trying to build it to grab the functions. So it's doing the things I told it to do, but notice how it's specifically doing this tool calling. It's calling the functions that are available to it in this environment to achieve the goal that I set out for it to do. And once it's done achieving that goal, it will then write this report for me in this QA directory, and it's going to save it, and it's saying, yes, I'm done. And that's great. So is it done? Did it actually do anything? That's the question that I always ask myself, and luckily I'm able to kind of see for myself. So here inside of my QA directory, I do see this file. So this file right here came from like the container that the agent was operating in, and they exported it back out using the same exact Dagger export system that exists for all other code. And we'll see that it created this really nice little report in Markdown. So let's just look at it as Markdown preview, and it did a pretty good job. It figured out that this was the, oh crap, sorry. I'm in VS Code. Okay, cool. Yeah, so like it did a pretty good job, right? It got some interesting information. It wasn't like it didn't succeed at finding the latest version because my modules are versioned, and for some reason it's not detecting them, and similar to the release date. It also can't find the Dagger trace, so it's still a little bit of work. I need to do some more QA on my QA module or my QA agent, but it did find the right Dagger engine version and reported it here. It figured out what the module does somehow. It was not able to find out what modules, which bums me out because it definitely has the ability to do so. So again, I need to do some more QA, but it gave me these suggestions, and I actually don't know if these are good or not. We'll be able to read them and take a look. It's talking about, hey, you should do some input validation. You should pin your version. So I don't actually know if these are legit suggestions or not, to be honest with you, but at least like the general kind of framework for what I want this to look like exists, and I'm happy that the report is in the correct form. So so I'm pretty happy with this, to be honest with you. Like, I think that some of this is like real and some of this is made up, but with some additional iteration and some additional maybe prompt massaging, I'll be able to get a pretty good result. And and that's great. So the title of this section was Autonomous QA Agent, which is extremely ambitious, and it's absolutely not what I just showed you. So how do we make this autonomous? That's the question, right? And here's what I think. Step one is, instead of me having to pass along a module explicitly, what would happen if I just said do QA? Well, what it'll do is it'll just go find some module. And this is using, this is using our kind of like a secret Daggerverse API that maybe I shouldn't be talking about, but like there's a way to get all the modules from Daggerverse and look at them all. And it's using that to just grab one. So this is randomly grabbed the GraphQL module from this user. And it's going to do the exact same thing that we just saw. So that's, in my mind, that's like step one of being autonomous, is being able to just like find other modules instead of having to be explicitly instructed to, grab the module that I just gave it. So it's going to do its thing. It's going to try to install some stuff. This one is like, I've never used this module before, so I have no idea what's going to happen. And we're going to learn together. And you know what's funny? I'm actually just going to try this against the one we just saw. So the iTwin AI module that we just saw in action earlier, I'm just curious what my little agent's is gonna tell, is gonna say. And I'm sorry, go ahead.
Oh, sorry. No, I see so many ways that we could use this from a community experience perspective too, of just like continuously going through all those modules, pinging people on Discord somehow, and saying, hey, update your module, it's really cool. There's a lot of things.
Yeah, for sure. Yeah, that's my dream too, is like find the right way to engage. So I have like some wish list items here while that's running. Like this is still incomplete. I think this is like I think it's like interesting enough to show, but there's so much work that I still want to do on this. And specifically, I want to be able to do more than one thing at a time. The technology exists. I know it does, but I cannot figure out how to use it properly. And you'll notice that I do want to show one thing. This is all public, so I'll share a link afterwards in GitHub. But the code to grab like the list of modules is pretty straightforward. I'm using JQ, grabbing from this endpoint, and like jumping into a JSON file. And then I have a separate function called sample that just grabs one. This used to be 10, so it used to do 10 at a time. But I've found that it wasn't able to actually finish, and it wasn't able to continue once if it ever failed. So I got to figure out how to get it to maybe make one more layer of sandbox, so it kind of dispatches jobs. It doesn't let it fail the main process. I don't know. So some experimentation left to do, but it's definitely going to be possible to do more than one at a time, which I think will be a big benefit, because otherwise it's just too slow. The next thing is I want to be able to test with multiple versions of Dagger engine. So right now my workspace is kind of hard coding the latest version of Dagger, and I want to change this to be parameterized and have a default of the latest. But this will allow us to have a really nice little table that says your module works with the last X versions of Dagger or not. And then, of course, get some cron jobs to make this thing just run all the time. And then I do have a Novu notifications module that I wrote, and I want to use it for this. So I imagine, like, I'm not going to start just emailing people. I think it's kind of annoying, maybe, I don't know. Or certainly, like, there should be some sort of opt-in mechanism, I think. I don't know. But for me personally, I want to email myself and be like, hey, like my modules aren't working. And I would love to just learn about that as like whenever that becomes true. Even if, I don't want to have to go manually kick off a bunch of jobs whenever the API changes or a new version of the engine is out. It would be great to just be notified that something went wrong. So these are all my kind of next goals. And once I get through this list, I might come back and show that in action.
Yeah.
Awesome. But in the meantime, we can look at the InterTwin CI module and let's see what this QA agent said. And I would love to get a validation if this is BS or not. But so far so good. And it's funny enough, it's saying, hey, this is the kind of advice you paid top dollar for. Because notice it's the same exact advice. It was like, hey, have you thought about version tagging and doing some more module docs? I think it's BS, because I was looking at your code and you have like amazing docs. Like even if you look in the Daggerverse itself, like it's very well documented. So shame on this module for giving this generic feedback. Let's see, anything? No, it's the same. It's funny. It's kind of funny. It's literally the same exact feedback. So we got to work on that. But it was still fun. Hopefully this is a good kind of example of what's possible with this technology, and I'm excited to see it continue to improve. By the way, all this demo was using Claude from Anthropic, but I do want to try this like with I'm going to add that as an item. multi-model. Like multi-model, just in general, I want to do it with different models and see which one has a more interesting result. But also allow folks to just kind of run this with additional agents to see if there's more valuable QA that can happen.
Awesome. And one thing that I think is interesting to call out too for people who are looking at this, not only can you look at your example, to build their own, but we have our agents quick start as well. So people can use that to get started. But now all those, all these modules and functions that you've built are in the Daggerverse. So, as you want to pull them, like you're saying, now you can use a Novu module in this, which I know you came on the community call months ago using that, and it's still useful and being used in many things. So, build it once, and now everyone can use it continuously.
Yeah,
great.
Yeah,
so, awesome. Well, thanks for sharing this.
I have so many ideas to talk to you about this. So,
yeah,
it's good to hear, because I got a lot of questions for you, Kyle. So we're gonna have
perfect.
That's a very nice session soon.
Yeah,
awesome.
Yeah. Hopefully, in a few weeks, we can tell the community how this suddenly is integrated in our whole flow.
Well, once they start getting spam from me about, have you thought about version pinning, or whatever, then they'll know we've reached the singularity.
Yeah. Oh, I love it. Well, this has been great, everyone. I really appreciate everyone who's been watching these demos and who joined us today to be on the community call with us and see these live. As many of you know, we also chop these up and put them on our demos forum in not only YouTube, but we also have a demos forum in Discord where you can see all of them. And we also tag the speakers. So if you have any specific questions on that, or you're looking for specific links that we didn't add for some reason, please go in Discord and ask them. Everyone is super friendly in there and willing to help you out. So thank you again, Diego and Mateo, for joining us, and love in your evening in Germany as well. And for those of you going to KubeCon, we will see you in London shortly, and we'll see the rest of you in Discord. Thank you so much. Have a great day, everyone.
Bye, everyone.
Thank you.
Bye.
Bye-bye.
And